Hello students, today we are going to see the typecasting and the inspection topic from the Swift. So whenever you work with the data, the type plays an crucial role. For example, if a function returns an integer, you know you can use its value in a mathematical expression. But what if the type information isn't very specific and you need to inspect the data more closely to determine how to use it? So here we are going to learn why some data can only be expressed using the broader type and how you can test for specific kinds of data before using it. We'll also see how to mix the values of different types into some same collection. Also how to check the specific type of value within heterogeneous collection, and also how to downcast an object to a particular type before accessing its properties and the methods. So you can see in the Swift, a function declaration determines the type of data to be written because the function can't return the three types at a function can't return the type. So here, suppose that here we have took one example. Let's suppose that the Brad's job is to visit the homes of his clients and to take care of their pets. So when he arrives at each location, he performs a different task depending on the type of animal. If the pet is a dog, he takes it for a walk. If it is a cat, he changes the litter box. And if it is a bird, he cleans the cage. So by only the function declaration determines the type of the data to be written because the function can't return the three types at a once. Okay, dog, cat, and the bird. So the best it can do is return the parent type of all three, that is the animal. So here what we have created, we function get client pet, it will return the animal, and let pet is equal to let client pet. Pet is a type of animal. Unfortunately, this type is too broad to be useful to the Brad. So without knowing the specific animal type, he could accidentally try to walk the bird, clean the dog's litter box, or clean the cat's cage. So here we will consider the valid functions with the dog, cat, and bird parameters as below. So if you have the let pet is equal to all client animals for the pet in the pet. So for the let pets is equal to all pets. Then variable dog count is equal to 0, cat count is equal to 0, and bird count is equal to 0. For pet in pets, if pet is a dog, dog count will be increased by 1. Else if the pet is a cat, cat count will be increased by 1. And else if the pet is a bird, bird count will be increased by the 1. It will be printed that Brad looks after the dog, cat count cats, and the bird count birds. So here, in case of typecasting, you can rewrite that like function walk, dog is a parameter, dog print walking, dog dot name, function clean litter box, cat. Similarly, function clean cage, bird. For pet in pets, if pet is a dog, walk dog, that is a pet. Else if let cat, pet as a cat, then clean litter box, cat, and else if let bird is equal to pet as a bird, clean cage, bird. So here we are using the optionals as or the as optionals for the typecasting. So for pet in pets, if let dog is equal to pet as optionals dog, walk dog. Else if let cat is equal to pet as optionals as cat, clean litter box cat, and else if let bird is equal to pet as optionals bird, clean cage bird. Also we are having the any. type. So in case of arrays, you have learned that by default arrays are the set to handle a specific type, such as integer, string, or the animal. Homogeneous collections are simpler to work because you know the type of every instance within them. But if you want to work with the non-specific types, Swift provides the two special types that are any and any object. As the name implies, any can represent an instance of any type, string, that is string, doubles, functions, or whatever, and any object can represent an instance of any class in the Swift but not a structure. So here we have an example of an array that can hold any type of instance or any. So variable items any 5 bill 6.7 and a dog. Because the array above can include anything, there is no way to guarantee the type of any item. For example, if you used items 0 to access the first item in the following array, it will return the value 5 with this non-specific any type. To go ahead and use the value of first item as an int, you would use then as optional operator. So here you can use like this first item as optional operator. Okay, like this, where items any 5 bill 6.7 dog. If let first item is equal to items 0 as optionals int print first item plus 4. That will give you the result as a 9. So this is the use of typecasting. If you go into the playground, we'll go to the playground. Typecasting and inspection. This will be the our creation. So if you go further,